Okay, so this time we in the section 3.7, which basically deals with the area and the polar curves. We're going to do example 3, which says that we are given r equals 8 times cosine of 8 theta, and that theta is between 0 and 2 pi. And we want to find the area covered by this curve. Now the graph of this equation is this. So basically you have 16 leaves. So you get 16 leaves by taking 8 times 2. So all of those are leaves. So you have 16 of them. Okay. Now they ask you to find the area covered by those regions. So basically all those areas, all those spaces. So we want to find the area. Okay. So to do that, what we have to do is, if we can find the area of this small piece, half of a leaf, then we can multiply it by 32 because we have 16 leaves. Now to get the area of the 16 leaves, you have to multiply it by 32, especially if you get the area of a half of it. So that's the deal. So we needed to get the area of this piece, half of a leaf. Okay. So if you have a leaf like this, imagine a tree with a leaf like that, a branch. So what we're going to do is find the area of half of it. Okay, so if you can find this area, with half of a leaf, then we can multiply. Then if we find this area, to get this, you multiply by 2. But since we have 16 of them, so times 16, so that's why we're saying we should multiply this half of a leaf, the area of half of it, by 32, so we can get the area of the entire curves. Alright, so let's do that. Now we needed to know the limits. So what are the limits of integration? So we start with x equals 0. So theta is 0. It will give us 8. So this is basically 8. So is this negative 8, negative 8. So then we needed to know, so when theta is 0, we are here, which is 8. So, but we need to know when when cosine becomes 0 of this function. So to get that value, we will look at this. So basically what we're looking for is what will theta be, so that we get, so that when you plug in that theta, we're going to get cosine to be 0. So we can rewrite the equation as cosine of 8 theta, which is this, should be equals something equals to cosine of some angle that will make a cosine 0. So since we have cosine, we can just match the two angles. So we get 8 theta equals pi over 2, and then divide this by 8. So we ended up with theta equals pi over 16. So we know that this curve will go back to the origin when pi equals when theta equals pi over 16. So that gives us the upper limit, or we can call that the lower limit. That's, since we're decreasing, so it's going to be the lower limit. So let's just look at this for a second. Anyway, we're going to then take, so we know this becomes our limit. So let's just rewrite this. Now, the area for a polar curve is given by the integral from alpha to beta of 1 over 2 times r squared d theta. Okay. So all I was doing here was to find the limits. So alpha is 0 and beta is pi over 16, which means we're only dealing with that half of a leaf. Okay, so we're dealing with half of a leaf. So just dealing with that. Okay. So, so therefore, our integral is going to be a equals to the integral from 0 to pi over 16 of 1 over 2 times. Now r squared is, so r is 8 times cosine 8 theta. So 8 cosine of 8 theta, we're going to square it, and then d theta. That's exactly what the formula is saying. You have to do that. All right. So we have this integral. We don't have to take the derivative. That's good. All we need to do is try to see if we can integrate this. So let's bring the constants outside. So we can bring a half outside. We can bring 8 squared outside. And then we have a 0 to pi over 16 times cosine square of 8 theta d theta. Okay, so what did I do? Well, I square 8 and then I square cosine. So when you square 8, you get 8 squared. Square cosine 8 theta, you get cosine square 8 theta and d theta. Alright, so now we need to integrate. But because we have cosine square, we cannot integrate. We need to go back and use the double angle formula. Okay. So now the double angle formula says this. So here is a double angle formula. Says that if you have 1 plus cosine theta, this should give you, so 1 plus cosine theta divided by 2 is cosine, so let's see, 1 plus cosine 2 theta. Let's start with 2 first. So 1 plus cosine 2 theta over 2 is cosine square theta. Okay. So now, so let's compare with us. Now with ours, instead of theta, we have 8 theta. So we're going to plug in 8 theta for theta. So if you replace this 8 theta with 8 theta to get this, then here we're going to do the same thing. We're going to replace theta by 8 theta. So that gives us 1 plus cosine of 16 theta over 2, which is cosine square of 8 theta. Alright, so we get the identity. So then, therefore, our integral becomes this. So a equals 64 over 2 times the integral from 0 to pi over 16 of, now we're going to replace cosine square 8 theta with 1 plus cosine of 16 theta over 2, and then d theta. Alright, so we then, you don't need this. So we got 64 over 2, which is 32. And again, we can bring that 1/2 outside. So which gives us the integral from 0 to pi over 16 of 1 plus cosine of 16 theta d theta. Okay. So now we can integrate. So we get a equals 16 times the integral of 1, which is theta, plus the integral of cosine is sine, and then divide by 16. And this is from 0 to pi over 16. So we get, so this will give us the area of half of a leaf. So let's see, what will that be? When we plug in pi over 6, pi over 16, we're going to get pi over 16 plus sine of 16 times pi over 16 over 16. And then minus, now if you plug in, if you put 0 for theta, and the sine theta, which is sine of 0 over 16, this whole thing is 0. Now, when you cancel 16 divided by 16 is 1, 1 times pi is pi, sine of pi is 0, so again, this is 0. So the only thing that survives is pi, because you're going to get 16 times pi over 16, which just gives you pi. Now, pi is the area of one leaf. So this one leaf here, its area is, this half of a leaf. So the area is, let's call that A of a half. It's pi. Now to get the entire area, we need to multiply that area by 32. So then if we call this 1/2, just tells you that it's the area of a half of a leaf. Okay, so now to get the total area, we're going to multiply, so the total area, so AT is going to be 32 times the area of that one leaf, which, a half of a leaf, which is, it gives us pi, so our answer will be 32 pi will be the answer of this problem. So, so A, which is AT, A total, is 32 pi. So the area of all those leaves, 16 of them, is 32 pi.